We will do one more example with L'Hopital's rule, and this is a little bit more interesting because we're going to have to apply L'Hopital's rule more than one time in order to find this limit. So if you wanted to think of this as being f of x over g of x, we could say that f of x we know is continuous and differentiable on the entire real line, as is the denominator, the g of x, which would be x minus sine x. So far L'Hopital's rule applies. And let's see, as x goes to 0, let's do the denominator first. 0 minus sine of 0, but sine of 0 is 0. So we know that that goes to 0. And the numerator, sine of 0 is 0, so sine of 2 times 0 is also 0. All right, they both approach 0 as x approaches 0. So the hypothesis of L'Hopital's rule applies. So this must be equal to the limit as x goes to 0, f prime of x over g prime of x. So we have to take derivatives. The derivative of sine is cosine, so I'm going to get a 2 cosine x minus, and the derivative of sine again is cosine, but I'm going to have to multiply it by 2 here. The derivative of 2x is 2, so I'll get 2 cosine 2x. And the denominator, if we take the derivative, I'm going to get a 1 minus cosine x. So now we reevaluate. What happens to the numerator and denominator as x goes to 0? Well, let's see. The numerator, we get 2 times 1. Cosine of 0 is 1. So 2 minus 2 times 1, right? Cosine of 0 is 1. So we get 2 minus 2, so that goes to 0. And the denominator is 1 minus cosine of 0. So again, they both go to 0. So what we're going to do is apply L'Hopital's rule one more time. So by L'Hopital's rule, and in case I forget to say it, these two are different. The numerator and denominator are both continuous and differentiable on the entire real line. So L'Hopital's rule still applies. All right, let's take the derivative. 2 cosine, the derivative of cosine is negative sine, so negative 2 sine x. The derivative of cosine is negative sine, so that becomes a plus. So I'm going to have a sine 2x. Then I'm going to have to multiply it by 2, so this is really going to become plus 4 sine of 2x. And on the bottom, the derivative of 1 is 0. Negative cosine has a derivative of sine. All right, so now what happens? As x goes to 0, sine of 0 is 0. Sine of 0 is 0. So we get 0 on top. Again, goodness. But we have two differentiable functions between the numerator and denominator. Both are continuous and differentiable on the entire real line. So we can use L'Hopital's rule even again. So let's take the derivative of the top. Derivative of sine is cosine. So we get negative 2 cosine x. Derivative of sine is cosine, so I'm going to get a plus 8 sine of 2x, since I had to multiply by 2 because the derivative of 2x is 2. Oops, that's supposed to be a cosine. And the bottom is easy. Derivative of sine is just cosine. All right, let's see what happens here. All right, we're getting something different because I know the bottom goes to 1. Cosine of 0 is 1. Cosine of 0 is 1, so I get a negative 2 on top, plus, cosine of 0 is 1, plus 8. So this is equal to 6. So applying L'Hopital's rule about 3 times, I guess, we found out that this limit is equal to 6.